Alrighty, so we are back. Uh, it is day 21. By the way, I don't know if you saw it or not. I mean, obviously, what am I talking about? Basically, that the video that I uploaded with no sound, it got like, if you can see here, it got like 29 views. And that ones that I uploaded yesterday, one in the morning and one in the night, day 19 and 20, got no views apparently. So yeah. Anyways, it's kind of funny. I just thought. So, yeah, whatever. We don't really care about that. We are here to grind. And today, sadly, there was nothing, nothing. There was nothing done by me about DSA and recursion in the day. So, I'm still in the part one, still struggling with part one. And there are still like 2 3 problems remaining, which has some lectures. So yeah, today also I'll have to continue with that only. Then we also have like 4 or 5 other problems on the part two, and then we can get to the questions. So hopefully not hopefully, I will basically finish these questions today and get to the part two. And I didn't I didn't submit the project today, although. So yeah, I still need to do that. I need to send a mail to the people of my whatever project team, or whatever. So yeah. Anyways, let us not talk about that. But yeah, hopefully I will. I'm planning to submit it tomorrow, regardless of whatever happens. So I have a report to do, and then I'll have to record the video showcasing the project. And yeah, then I'll pack everything inside a folder, and then we will be good to go, and we can submit finally. So, anyways, that is it. Hopefully, I will. Not hopefully, I will surely submit the project tomorrow so that I can focus. I can start focusing on DSA and other development things. But anyways, we have another problem right now with recursion, which is it's write a function to find the first occurrence of an element in an array. Okay. So we'll have an array, and we'll need to find the first occurrence of the given element. So first we'll start from the index 0, and if it does not exist on 0th position, then we'll go on to search further. If it does exist there only, then obviously we'll return that. And we can return whatever. Let's say it's on the 4th index, so we can return 4, and then everything will return 4 from that. And if it does not exist, and let's say we are on to the last element, And if till the last element, which is basically n minus 1th element, if we don't find it, we can just return minus 1, which is like, which is saying not found, because that's not a valid index. Let's say first occurrence, and we are passing an array int I and int key. So this will be the case in which we find, basically wherever we find this key on whichever index, we can just return that. And if we don't find it, we can just call it again by saying this. And yeah, if it is not found, then okay. Okay, so that we can write in base case. Yeah. That's our arrays. Let me just make changes here. It is 836 9 5 10 9 5 10 2 5 3. Okay, and we can just call first occurrence. Let's say we want to find 5. And our I will be 0 in the beginning. So let us see. And we are 0 1 2 3 4. Yeah, it's on the 4th index. We can also pass 3, because 3 is occurring 2 times and we need the first occurrence. So it should return 1. Yeah. So the time complexity of it will be big of n in the first case, in which we are having to check the entire array, and otherwise the space complexity is big of n because we have n stacks as always. Not as always, but yeah, in the most cases that we have seen so far. So the next question is kind of similar. It is to find the last occurrence of an element in an array. Okay, so let's say if we have the same array, so basically first we were doing that, we are comparing with ourselves and then looking forward. So basically, let's say we are going from here, we are searching from 5. So when we come here, we'll compare with ourselves, and then we won't look forward because we have found the first occurrence here. But here, what we'll do is we'll keep looking forward, and if we don't find anything here, then we'll compare. So let us just copy this part from here, and yeah, I can also do this. Let's say int and let's change the name here. Now we can check that if is found is not equal to -1, and that means that we have found something. uh, we have found the last index basically. So then we can return this, otherwise we can return this. So I think this is not needed because okay, so I think we also need to check with ourselves. Yeah. Okay, so that condition will remain same, which is here. Okay, so there is a bit cleaner syntax to this, which is that if this and this, then we can return I. Let me just remove these, and if it is not, then we can just s1. So let us just make call for last occurrence. Okay, so I think we are doing something wrong here, which is what? Our array is okay. If okay, so we are reversing this condition as well. So we are saying if is found is equal to minus one, and array of key is equal to key, then we are returning I book. Yeah, so we are getting 7, which is this one. Okay, so let us move on to the next problem, which is to print x to the power n. So let us make a function which is public static main, sorry, int power, or let's say x to n or something like that. No, let us just say power. That would be better. Let's say int x, and okay, sorry. Let me just remove these. So first we are calling it for xnm1, and we are saying that we'll find power of x to the power n minus 1, and then we can just return x to the power n as x multiplied by x to the power n into sorry, x to the power n minus 1. Then we can just return x to the power n. And if n is equal to 0, or if it n, okay, yeah. And we can do it this in single line as well, which is this. Uh, let's comment out this array. Let's say power, and let us give 2 to the power 5, let's say. So yeah, that returns 32. And okay, so after analyzing the call stack, this also has the time complexity of big O of n. Let's say we have to calculate like 2 to the power 10,000 or something. That will be a really huge number. So there is a way to optimize this, and we will see that next. Okay, so now we are on to the optimize way to do that. Uh, let me check what is time. Okay. So, anyways, I might do this as the last question, and then I might go out. Not out like that, but you know what I mean. Might stop the recording, and then, anyways, let us just finish this first. So we are reducing the time complexity from big O of n to big O of log n. So let's say we are taking the case one as when our n is even. So let's say we want to find 2 to the power 10. So we can break that down into x to the power n minus 2 into x to the power n minus 2, which will be 2 to the power 5 into 2 to the power 5. So that will be 2 to the power 5 plus 5, which will be equal to the power 10. 2 2 2 2 2 2. That's what do you call it? Tongue breaker? I don't know. Tongue twister. Yeah, that's a tongue twister. So let's say case 2 is for odd thing. So that can be calculated as x into x to the power n by 2 into x to the power n by 2. So it should be, let's say if you want to calculate 2 to the power 5, so that will be like 2 into 2 to the power 2 into 2 to the power 2. Okay, that was definitely a bigger tongue twister. So we are just breaking it down after doing 2 to the power 5 and 2 to the power 5. We are breaking it further down and then simplifying the calculation on each level. So let us write code for that. Uh, so we can call for and again power optimized x and divide by 2. And let's say this. So first we can check if n is odd, then what can we do if n modulo 2 is not equal to 0, then we can multiply x with this half power square, or we can just update. Yeah, we can just update it. And obviously we have the base case, which is this. Let's say this. So yeah, we can run it. And obviously we have the output as 32. Oh, so this function still has the time complexity as big O of n, because we are calling this function two times. So we can study that in detail in the time complexity chapter, but for now let's focus on getting it to log of n. So let's say we can make another variable called half power, which is this. So we are just squaring it now. Alrighty, so we are done with the chapter 1 finally, and yeah, I think that is it for the day. I will be stopping here. I think we did for a good half an hour. Yeah, we did for good half an hour. Uh, I'll most probably be finishing this tomorrow because I don't want to continue it any further, and then we can at least do the divide and conquer chapter in another 2 days, and then we can move on to time and space complexity. So yeah, hopefully, although I will be completing the lectures before recording this, and then maybe I tomorrow itself I can do the practice questions. But yeah, let's see what we can do, and because I also need to still revise the stuff and write out in my notebook, which I have taken it out, but I have not started anything into it. Maybe I'll start a little bit itself right now. So yeah, that is about it. We have project to submit tomorrow finally, and then hopefully we will be going all in DSA and our React journey as well. Although I'll still have to study Vue in detail because of the Viva that I'll have about project, and they ask like a lot of in-depth questions and stuff. So, anyways, we'll be doing a little bit of Vue as well. Maybe also that also I can cover in these videos. But yeah, let's see what we can do. Anyway, so that's it for today. I'll be heading out for now. We'll upload it after a while. And yeah, anyways, so if you're seeing this, have a great day or night. Uh, Thank you for being here if you're watching. And yeah, signing off. Bye bye. It's day 21. Yeah, bye.